Hello everyone, I would like to share what I learned this week about the AI stuff. It could be the AI models training, or it could be the how to accelerate running AI models smoothly, efficiently on the target devices. So on Monday, I posted an article talking about the difference between loss function and performance metrics, because the beginners would get confused what's the difference between the two and how to design the loss function and performance metrics. So simply speaking, loss function is used for the models to learn. So it's used in the training process. So whenever we need to update the weights of the model, we need to use those functions, because that's a function that we can find out the directions to update the weights of the model. So loss function, it's for the model training process, and for performance metrics, it's we would say it's like KPI to evaluate if the trained model is qualified to use or not. So basically, it's a metric for people to understand if this model is qualified to use or not. And the common one is like accuracy. People always talk about accuracy. That is the performance metrics for people to read. And from the perspectives of the mathematics, loss functions, it needs to be differentiable, because we would use ways to differentiate the loss function. So it needs to be differentiable for the ways to find directions to improve itself. And for performance metrics, it doesn't need to be the differentiable, and actually most of the time it's discrete. So from the mathematics perspectives, the difference is it's essential and it's required for the loss function to be differentiable, and this is not necessary for the performance metric. Alright, so this is what I posted on Monday, and so the next day is the Tuesday, or maybe Wednesday. I shared something related to chain root. People might ask, why do we need to learn calculus? And one of the key concepts in calculus is the chain root. And as mentioned, we would update the weight of the model using the loss function. And when we need to differentiate the loss functions that's composed of the many functions, then we need to use the chain root to run to do the differentiation. So chain root is used in the back propagation process. And how to explain it in a much easier way? It's like the loss function. It's a function, right? So inside loss function, we can see the inner function. So we can have multiple layers of the inner functions. So the chain root tells us to start differentiation from the outside, and then step by step we go to the inside, and then we can find out the final result. So it's a mathematics method for us to run the model updates when it comes to the model training process. And on Thursday night, I showed some of the examples of the chain root, just like how to use the chain root to update the weights of the AI models. And it's used something like sigmoid. We can ask a question: do we know how to do a chain root on the sigmoid function? and can we run the chain load on the loss function? So something like this. And the next that is I think 2 days ago, I shared a post about using Llama.cpp to run the language model, and the topic I share here is how to choose the GPU backend, because Llama.cpp it's like a framework for us to run the language models on the GPU device. And however, from the perspective of the lower level, Llama.cpp need to have a different backends to run the GPU. So for the NVIDIA GPU, it's suggested to run under the CUDA backend. And if your computers do not have an NVIDIA's GPU because it's too expensive, in this case, then you can use Vulkan, because it's a cross-platform GPU API that can support you to run actually most of the GPU you have on your PC or any devices. For OpenCL, it's recommended to use it on the mobile devices, because it's a framework supported by Qualcomm, and Qualcomm is the leading company to support the mobile device. So that's the reason why we would suggest you use OpenCL framework to run the Llama.cpp on the mobile. And Metal, obviously it's like this ecosystem that Apple's chips will use. So this will be the top choice for the Metal for Apple users. For SYCL, I'm not familiar with this one, but it's the one that Intel's recommended to use. So if you have Intel chips, then it's one option for you to use. ROCm and HIP high, I think the high heterogeneous something. I forgot this the full name of it, but it's like something for high performance. It's a framework introduced by AMD. So if you have the AMD GPU, then you can use it. But one thing you have to remember is that it's more for the Linux system and the data center. And DirectML, the next one is Windows GPU layer. So if you want to run your devices on GPU, then this is the option that you can choose. And so today I also share another topic, the multi-loss function, because we always talk about design of loss functions, and some of the cases we will not just design a single loss function, we'll have multiple loss functions. In the real AI world, the one loss functions cannot meet what we want to complete. For example, like the object detection models, we want to find objects on the image, but we cannot just find what the object is. We also need to where the object is. So where the object is and what it is. So we need to have two loss functions. The first one would help us to find out the bounding boxes, and the second one is to find out what is exactly inside the bounding box. We need two loss functions to work together to complete object detection task. So this is one classical example, but actually many others also use multiple loss functions to train a model, like OCR or the signal recognition, and even the most popular large language model, and also again, they all use the multiple loss functions to train the model. So this is what I learned and what I share on the social media, and that's my right of the content here. Okay, thank you for your listening. This is what I would like to share today. Have a good one. Bye bye.